Hello and welcome to the tutorial on Retico. Retico is a framework for building state-of-the-art incremental processing systems, specifically spoken dialogue, but it can do a lot more than that. Um, what we want to use Retico for is to allow you to rapidly give your systems, whether it's a robot or a virtual agent or something else, the ability to have spoken dialogue capabilities. Some really important things about Retico that sets it apart from other frameworks and an off-the-shelf language model is that Retico works incrementally. And what we mean by incrementally is that it works as early as possible as it processes as much as possible as early as possible. For example, if I use an off-the-shelf speech recognizer and language model, what that will do is it will allow me to speak to a robot, but it would require me to speak in complete sentences and wait till I'm done speaking before it processes, and then it takes the transcript of the speech recognition and sends that to the language model. The language model processes that and then sends a response. Incremental means we want to work at a more fine-grained level. We want to not wait till the end of your utterance, but to process at the word level. This incremental processing stuff comes from a theoretical model called the incremental unit model. The incremental unit theoretical abstract framework. So this is work by Gabriel Scanza, David Schleiman. The idea is to give an example is this. So if this is a speech recognizer and I'm speaking into a microphone that is then passing information to the speech recognizer's job is to transcribe my speech into words. And if I say a phrase that has the word 40 in it, the incremental processor, an incremental speech recognizer would take the word, would recognize the word for as I'm saying the word 40 and produce output and say, this person said the word for. But then realize just a moment later that it was a prefix for me saying the word 40. It would then say, okay, actually, never mind. That person didn't say for. That person was saying 40. This is good and bad. The good part, the bad part is that if I wait for more information, it would have just known I was saying 40 and it wouldn't have had to change its mind. But the good thing about this kind of processing is that it can process very quickly and send output very, very quickly. And you want that for things like robots and IVAs because people want to know that it's listening and that they can interact with it and speak to it and not have to wait for a while for it to respond. So this is actually a really powerful idea that you can update your hypothesis given more information. Incremental systems are based on modules, so there's different ways you can hook up all the modules. And we offer many modules, over 40 at this point, and modules range from speech recognizers to dialogue managers to object detectors from computer vision. The important thing to note here from this is that the information that's passed between modules is called an incremental unit. And an incremental unit isn't anything fancy, it's just a bit of information. So a speech recognizer's incremental unit would be a word. And you, the software writer, the system designer, gets to decide what the incremental units are. We give a lot of built-in incremental units with Retico, so you can use the ones we have, and that covers probably 90% of your use cases, but you might have to write your own. So we'll explain that a little bit here in a moment. So Retico, just to go through this, is supported by the National Science Foundation. You can look at individual documentation on how to install, but I will show you an easy way to get it up and running without anything super fancy. There's some example systems here that are very nice. You can look at a visual question answering system, emotion tracking, some other things, and you can look at example code. Most of these are open source, so you can clone them and use them yourself. One thing I want to get you started with Python is the runner script. That's kind of the vernacular we use for on the Retico team. A runner script basically it tells the system how to hook up the different modules and how to pass information between them. So if we import all of the modules, in this case, I have a microphone module, a speech recognizer from the Wave to Vec model. This plays back speech into a it dispatches words to a synthesizer, and then this plays it out on the speaker. And then this callback module is just a simple thing that calls this function right here, and it looks like it just kind of logs information to the console. This part, so the first part is you import, the second part is you instantiate all of your modules, and the third part is you simply subscribe modules to each other. And this is how you tell a module that you want its output to go to a different module. So M1, which is the microphone's output, goes to the speech recognizer. The speech recognizer's output goes to the text dispatcher, and so on. This is a pretty simplistic system. You can hook up modules in many different ways. For example, you can hook up the speech recognizer to 3 or 4 different things at once, and it will send the IUs, the incremental units, to all of those modules. And then you turn the first module on, then this kind of goes through it and turns all the subsequent modules on. Input waits for input from the user. So if you press enter, it goes to this point, and then it waits for you to press enter. When you press enter, then it stops everything. And I'll show you why this is important, because in a lot of these modules have setup, like you need to hook up to an API, or you need to hook up to a robot, or you need the module to spin up some threads or something like that. And then at the end, after you press enter, that calls the takedown functions, basically. Some additional things we have besides modules are monitoring and logging. We're working on a visualization tool, should be out soon. And then there's some examples of research that's been done with Retico. And if you use Retico, we ask you to cite the original Retico paper. If you use any of the multimodal modules like vision or robots or anything like that, we ask that you cite the RRSDS papers. Just to give a quick survey, everything in Retico is a repo. So there are a bunch of modules in here. So we can see that there's a prefix for Retico dash whatever it is. Retico dash Misty Robot. There's some bindings for the Misty Robot, bindings for Gemini. There's CRISPR ASR, ChatGPT, YOLO V11. We have basically any of the YOLO models. We have Dino V2. Whisper ASR is there. We have Ross Bridge. We have Zero MQ, synthesizers, all kinds of stuff. So that's just an overview of the GitHub team. Now, what I would like to do is show you how to get started building your own Retico system. The first thing you need is something called Retico Core. Every Retico system needs Retico Core. Just type core here. You can pip install core, but it's an older version, so don't do that if you want to use the newer version, which you do. We are working on pip installation and poetry for these modules, but for now, what you need to do is just clone it. So you can put these in a folder. Oops. So if I just clone this in here, that is there. It's a small package, but it has all of the stuff you need. It has the abstract classes for modules for incremental units, and then there are some very common modules that we use for audio processing, like the microphone, for debugging, for dialogue system building, and so on. So you need core first, and then you can decide, okay, now that I have core, what ASR do I want to use if you want an ASR? So you can search for ASR. There are more ASRs than this. Let's look for Google, actually. So here's Google ASR. And if I want this, I can go ahead and clone this. And you'll notice that each of these modules have their own installation requirements. They have their own README. So you need to note any additional installation requirements for each individual module. So in this case, for example, if I don't pip install this, if I just clone this, I need to at least be sure to install Google Cloud Speech. One thing to note is that different operating systems handle audio processing differently with Python. With this operating system I'm using, this is Ubuntu, I had to install PyAudio, but PyAudio won't install unless you, back here, it won't install unless you make sure you have some of the port audio packages installed for it to compile. So I had to apt install port audio 19 dev and Python 3 PyAudio. And then I had to copy a file, the libstdc, to my environment, to my conda environment. So I went ahead and made a new conda environment just to show you what that looked like. I created a new conda environment called Retico, and I set it to Python 3.9. Because some of the packages that we use do require older versions. Like the Google ASR is a little bit older, so I'm using Python 3.9. So I have Retico activated right now, and then I went ahead and installed PyAudio, also the Google Cloud Speech API. So that's all there and running. So once you've copied those down or cloned those, I can start building a runner script. And I'm actually going to use a runner script from somewhere else. But the runner script, the way we bring it into, there's a lot of ways you can make this work, like with Python, with Poetry or other class path management tools. What I have here is setting it up without any of that stuff. It's all just in the script here. So I'm going to import OS and sys, and what I'm going to do is set environment variables to the paths of the files of the things I just downloaded. It should be Retico-core. I changed this on an earlier version, and then Google ASR. So we're not going to use Wave2Vec ASR in this example, but that is another thing you can use. And the nice thing about Retico is that if I decide to use 3 different ASRs, I can instantiate all of them and I can just plug them in. I don't have to worry about the incremental units working between them. So I'll show you my module here in a second. So what I'm going to do first is set up a very simple system where I'm going to use the microphone. It's going to output its streaming information to Google ASR, and then I'm going to just have the Google ASR output go to the debugger. The debugger just prints output. So those are the 3 modules I'm going to instantiate. So I'm going to import those, and then I'm going to instantiate those 3 modules, and then I'm going to subscribe the microphone to the ASR to the debug, and then I'm going to run all of them. This is the old school way of running. You can also just do run and stop, but I'm going to do it this way for this example. And then if I do Python runner, I named this thing runner.py. So if I run that, why do I need that? Sorry, wrong one. Oh, this isn't going to work because I have the speech recognizer, or I have the my microphone hooked into Zoom, so I can't pipe it in both places. So the device is unavailable. But it does work, I promise. So that is a simple system that hooks up the speech recognizer. Notice also that with Google ASR, it requires you to have your own Google application credentials, which I have set here. It's a JSON file. There's instructions in the Google ASR repository on how to get that. So that information's all there. Okay. Now what I want to do is show you what a module is. And the way I'm gonna step you through that is I'm going to show you this simple module that I made. And this simple module has also a custom incremental unit. So my module is going to extend abstract module. Abstract module comes from Retico core. So if I extend the abstract module, there's some required functions that I need to override. One is called name, and all that does is return a string, which is the name of my module. The other one is a string called is a description, and that returns a string called um, a string for the description of this module. And then there are two really important functions, which is what are the input IU types and what are the output? What is the output IU? There can be different types of input IUs. You can list them all here. If there's 5 different types or 1 different type or 10 different types, it doesn't matter. You just put them in this list. For the most part, modules only need one input type. In this case, I'm just getting a text IU. And the text IU comes from speech recognition IU. That's output is a type of text IU. My output is going to be of an incremental unit, and it's called my custom IU. Let me show you that very quickly. IUs are IUs because they extend the incremental unit class. And the type here is a string. And in this case, I'm not doing anything special with it. It's just an instantiation of an abstract incremental unit. But you can add all kinds of functions here if you want to. You can add setters and getters. You can package the information in any way you want. In my case, I'm not doing anything special. One thing that all of the IUs have is something called a payload. So I'm going to set that down here. And the payload is the information that is sent between the different modules. Okay, I have my constructor for this particular class. In this case, I'm going to take in a list called keywords. Let me show you what the keywords when I instantiate my module. So let me try to bring in my module into this. I'm not actually going to run this, unfortunately, because the speech recognizer or the microphone is tied up with Zoom, my recording here. But I have a list of keywords. In this case, it's Boise and potatoes. So what I want my module to do is look for those words, just spot those keywords. If someone says any word in that list, output that word as a custom IU. So first I need to know where does input come into this module. Input comes into modules in the process update function. This process update function is an abstract function that you have to override in your module. So in this case, I get the update message, and the update message is a list of tuples, and the tuples is the IUs and the message type. The message types are of 3 different types. 2, the most common, are called add and revoke. Add means means that this is new information I'm adding to the incremental unit network. So getting this incremental unit means this is new information that you haven't seen before. And you need to process it. So in this case, I would be getting a text IU from the speech recognizer. So it's recognized a new word, and I just need to know that that word's been added, and now I can process it. If it's a revoke, it means that the speech recognizer sent me a word before, it added a word before, but now it wants to take that back. And it acts as a stack. So if I'm going to revoke something, it has to only revoke the latest thing that I said, that the latest IU, but it can have multiple revokes, but it acts as a stack. So if it revokes 3 times in a row, it always revokes the latest thing. And in this case, process IU just means now I need to actually perform the function of this module. And the function of this module is to check, is the word that I'm getting in this IU in my list of keywords. So the way I get that is I'm going to grab the payload, and the payload is actually a list of words. And I'm going to grab the first word in that, and lower. Actually, it's a list of words, but it's usually just a list of one word. So I'm going to grab the one word in that list and then make sure it's lowercase. That's going to be this string. That's the word. And I just check, is that string in this keywords list? If it is, now I'm going to create a new IU, which is of this type. It's of my custom IU type. So this is my custom IU. I'm going to set its payload to the word that was found. And then I'm going to package that in an update message. So I need to tell it this IU is associated with an add. So the next module that I send this to knows that it's new information. And then when I do self.append that message, that means this is going to send that message then to the next module that this module is subscribed to. And so in this case, it would send that IU to the debug module. This one should be mine, just to make it clear here. That's it. So this module, all it does is look for keywords and pass them along. Everything else it kind of ignores. That's all this module does. There are much more complex modules, but this is a good place to get started. So that is an example of a simple system. That is an example of an IU, a custom IU, and a custom module that you can get started with. Our hope is that we have enough modules for you to get started and you don't have to write very many of your own. We have speech recognizers, we have modules for robots, we have bindings for Copilia Sim. If you have a lot of stuff running on ROS for your robot, our modules can hook into ROS. But this is just an introduction to help you get started understanding what modules are about, what IUs are about, and then of course how to build your own system. And that's what we have here. So if I ran this, what would happen is as I talk, it wouldn't output anything. But if I say the word Boise or potatoes, it would output those IUs as a keyword spotter. So that's it for today. I hope this has been helpful and good luck. And if you have any questions about Retico, do please let us know.